Hello there, chemistry folks. How's it going? Hey, I miss you. Really, I do. This next unit we're going to be doing is a little tricky. Not that there's nothing new. Everything that we're going to be doing in this next part is you've done before, but what's different is the way it's pushed together. And the other thing that's kind of tricky is that we're going to have to drag stuff forward with us that you did in January, end of January. And that's always tough. You know, you think when you take a test on something you can just be done with it and forget it. Well, that's not how it works in chemistry. Sorry. So what we're going to do, our goal here is to take stoichiometry that you've done before, you're professionals at that, and we're going to add gases to that. Okay, so remember stoichiometry was you have a mass of this stuff and then it reacts in some way and then you get so much mass of this other stuff out. That was stoichiometry. You got that down, I hope, right? Now what we're going to do is we're going to add gases to that. So instead of having a mass of this, we'll have a volume of this gas. Right? And then we can have a volume of the gas on the way out, or mass of a solid on the way out, or we can start with a mass of a solid on the way in and have a volume of a gas on the way out. So you can kind of see it gets a little tricky. You got to keep it straight. It's going to be real important that you plan out what you're going to do. Right? You got to make sure you know where you are. You got to make sure where you got to get to, and you got to figure out how you're going to get there. It kind of sounds like life, huh? Yeah, it's life there. So that's how it's going to work. You're going to need to the stuff we just did with these gas laws, all right? Because remember, with a gas, you can specify a volume of a gas, but it doesn't really mean anything unless you know the temperature and the pressure also. Right? You got to have the temperature and the pressure, right? And then if you know the volume of the gas and you know the temperature and the pressure of the gas, then you can know how many moles of the gas you have, and that's how you get in and out of moleville by that reaction PV equals nRT. Right, remember that. Right, remember on that map we had those two reactions? You know, one of them, or two equations. One of them had that V1, P1, T1 thing, V2, P2, T. Yeah, we're not going to worry about that anymore. We're done with that for now. All right. The only one you have to worry about is this PV equals nRT. Okay, that's the one that you need. That's the key. So let's get going. Okay, so we got to review a little bit. First of all, remember this guy? We're not going to be using this part anymore. Okay, only this part. And remember, the tricky thing about a gas is you can't just say 10 liters of a gas. That doesn't really tell you what you have, because you also have to specify the pressure and the temperature and the number of moles. And then if you have pressure, temperature, and number of moles, then you can specify the volume. Okay, so you need all four variables. Well, if you have three of them, you can calculate the fourth. Remember, we got this pesky R. This is this gas constant that's up here, right? And it varies depending on the units of pressure. It's not always the same, which is kind of a pain. It'd be nice if we could just pick one pressure and use that one, but that's not where we're at right now. So we have atmospheres, millimeters of mercury. This is the same as torr. I don't think you'll see that, but millimeters of mercury or torr, and then kilopascals, you use that. So you got to keep that straight. And then the other thing you might see is the standard temperature and pressure. Now, it's actually not 1 atmosphere anymore. Hopefully I don't damage you forever if you take this in college. It's actually 100 kPa. They changed it somewhere along the line. I don't know. When I was in school, it was 1 atmosphere. But this is basically the same. This is what, 0.99 something atmospheres. I don't know. But for our purposes, we can keep using 1 atmosphere. But if you see it in college, it might confuse you. Okay. Another thing you got to remember. This dude. Now, you've met this guy before, but I didn't hand it out because we only had one way through here. We started with grams, and it's grams, and this is what's called stoichiometry. So we've got a mass of something, in this case A, Then it goes this chemical reaction, produces some C. This would be a synthesis reaction, right? And then we have so many grams of C on the way out. So we've done that before. You're already professionals at that. But now what we're going to do is we're going to add the volume of the gas. So again, you got to get the Moleville. Right? You can't hang out here, so you got to get the Moleville. So in order to do that, you have to use this guy down here. Oh, this guy right here. I mean, that's how you get to Moleville with gases. And so you start with the volume of gas. Use this to find the number of moles. That's N. Now you're in Moleville. Now you just use the reaction, moles of A, moles of C. And then on your way out, you can use this again to find the volume of the gas. Now, the thing that's tricky, though, is you can start with grams here and end with volume there. We can start with grams here, volume there. There's 4 possible routes through right now. And so what I would recommend doing is putting this guy in one of these plastic sleeves and say, I'm starting here, I got to go there, and I got to come out here. And that'll help you keep track of where you are, where you're going, and how you're going to get there. And remember, the whole goal is you got to get through Moleville. And the question is, how are you going to get in and out of Moleville? Okay. That's good enough for now. Okay. On the resources section of this class, there's some sample practice problems. So we're going to go through these together first. And this is the first one. This step 1. You got to get the reaction right. In order to get the reaction right, you got to get the formulas right. In order to get the formulas right, you got to get the ions right. So very important to pay attention to this. You could read this, say aluminum chloride, great, AlCl, and on go on. And you'd get it wrong because it's not aluminum chloride. Right? Aluminum is 3 plus, chlorine is 1 minus, so it's AlCl3. Okay, you got to get that formula right. And it's going to decompose, so bam. And it's going to produce chlorine. Remember, chlorine is diatomic on your ion list. Now, obviously, there's something missing. Well, it's also going to produce some aluminum. Right. Now, it's not balanced. We've got the 3,2 gig here, so we need a 2 here and a 3 here. Sorry, I'm making this a little crowded. Shouldn't have done that, but... and then we need 2 aluminum over here. So there's our balanced reaction. And you got to do that right. Everything, odds are it's going to be wrong if you don't do that right first. Okay, so that's step 1. Now step 2 is what we did here. I kind of got ahead of myself a little bit. This was step 2. All right, our plan on how we're going to get. We're going to start here. We're going to end here. This is how we're going to get there. All right. That was step 2. Now, in step 3. We got to take what we're starting with. We need to figure out how many moles of how many moles of chlorine are we going to have. And that's the starting point. And so we have this volume of chlorine at 32 liters. Okay. The pressure of the chlorine is at 2.3 atmospheres. Right? The temperature of the chlorine is at 200 Celsius, but you still have to do this Kelvin thing, right? That's not going away either. So it's 473 Kelvin. And I would put the R down there. It's not a variable, but it helps to keep it straight. In this case, our pressure is in atmospheres. So we're going to do a value of R 0.0821. You can put the units on there. It's kind of ugly though. I mean, it's what, atmosphere, liters per mole Kelvin. I don't know. I'm not going to worry about that. Okay, and our equation is this. Rearrange it before you plug in the numbers, please, please, please. So the moles, that's N. The moles is equal to PV over RT. And you slam these numbers into there and you get, what do you get? 1.9 moles of chlorine. So, welcome to Moleville. All right. Well, let's leave that on there. We are now right here. Right. We've converted from volume of gas to moles of gas, and we are now in Moleville. Hello, Moleville. Now what we need to do is we have to convert moles of this gas to moles of the aluminum chloride. Right. So we have 1.9 moles of chlorine gas, and so we need moles of chlorine on the bottom. We need moles of aluminum chloride on the top. The mole ratio is 2 to 3. Got that? 1.9 times 2 divided by 3, and that gives you 1.3 moles of AlCl3. Okay, so now we are right. We're still in Moleville, technically, right? We're right there. We've converted from moles of chlorine gas to moles of aluminum chloride, but now we need to leave Moleville, and we need grams. And you can see these little numbers here. 1, that tells you need to use the periodic table. Notice we didn't use the periodic table here, right? We just used these gas laws. So, but now, since we're going to grams, we have to use the periodic table. Now, aluminum is 26.98. You get that from the periodic table. Chlorine is 35.45, but there are 3 of them. And add that all up, and you get 133.33 grams per mole. That's for the aluminum chloride. So we have our 1.3 moles of aluminum chloride, and it's 133.33 grams per 1 mole of aluminum chloride, and you get 173.33 grams of aluminum chloride. One thing you got to be careful of that I still see people doing, unfortunately, is you got to keep these straight. That here and here, you do not use the reaction. Okay, the reaction has nothing to do with this step. The reaction has nothing to do with this step. In here, you only use the reaction. You don't use the equation or the periodic table or anything. Because what will happen is you come down here and you say, we're converting this moles of aluminum chloride to grams. You'll say, well, wait a minute, right here. 1 mole of aluminum chloride. No, we have 2 moles of aluminum chloride, and you try to put a 2 down here. But you can't do that. Right? These steps here, steps 2 and step 3 and 5 have nothing to do with the reaction itself. Right? And in step 4, the reaction, we didn't use the periodic table. So you got to make sure you keep that straight. This periodic table is always grams per 1 mole. Okay? There's another sample problem. And it would probably be best if you went and did that now. I'll go over it with you, but you might want to go do that now and see how it goes, and then you can come back and see how it went. So, shoo, go away. Bye. So, how'd it go?